Alright, so now that we have finished talking about the four primary types of tissues, we'll talk about how the tissues actually, or the cells bind together to actually form the tissues. So some factors that bind cells to form a tissue. Remember when we talked about the plasma membrane? On the surface you have glycoproteins that can allow the cells to interact with each other. And some cells will basically have wavy indentations that just kind of fit together. And we'll talk about the three main types right now. So the three types of cell or membrane junctions are tight junctions, desmosomes, and gap junctions. And most of the cells in your body are going to be bound into a community to actually form a tissue. You do have some cells that are free floating around in your cell, like blood cells and sperm cells and the ova, but most of them are going to be bound into communities. So a tight junction is whenever the plasma membranes of two cells are physically touching. They're basically protein molecules on each of the cells that fuse together tightly, and it forms like a zipper. And these are really important because they prevent fluids and molecules from being able to travel between the two cells and from getting out of where the tissue would actually be surrounding. So where might these be useful in the body? Areas like your small intestine that's filled with digestive juices from your stomach and from your liver and your pancreas. You don't want those getting out into your blood. So on your diagram, this very first area right here shows a tight junction. As you can see, these protein molecules are causing the cell to physically touch each other, and so nothing will be able to seep through and get through those areas. In a desmosome, the plasma membranes are going to be extremely close, but they will not actually physically touch each other. You actually have keratin filaments that are going to hold the cells together. It forms somewhat of a spot weld. These give stability to a cell, but they also allow for expansion, and it reduces the possibility of tearing. So locations where you'll find these are areas subjected to great mechanical stress, such as your skin, your heart muscle, and your uterus. So here on these, we see the desmosomes. So these are the keratin filaments that you can see going in through that area. And this is the area where they're going to be somewhat welded together. And then the last type is called a gap junction. And in this one, the plasma membranes are close but also do not touch. For these, they will have hollow cylinders called connexons that are going to actually connect neighboring membranes. They will allow for the passage of ions, sugars, and other small molecules to actually go from one cell into the next. So this is important for embryonic cells because in the first stages of embryonic development, you do not have a circulatory system. So the way that the cells will actually pass along nutrients is through these gap junctions in between the cells of the embryo. And then cardiac muscle, you will also see gap junctions as well. So the very bottom one shows the gap junctions. So as you can see, here we have the plasma membranes. This is the interstellar space, so they are not physically touching. And these are going to be the connexons. They form little channels in between the cells. So you can actually have material going from this cell, into this cell, into this cell, into this cell. All right, so now we're going to talk about the covering and lining membranes of the body. These are going to be composed of at least two primary tissue types. It will have an epithelial layer, and then it will be surrounded by an underlying connective tissue layer. And they are considered simple organs. We have three types: the cutaneous membrane, the mucous membranes, and the serous membranes. And this is on the picture in your diagram page. So your cutaneous membrane is just your skin. It's made up of stratified squamous epithelium, like we talked about in class, which is your epidermis. It says it's keratinized. Keratin is a protein that's going to make your skin tough. And then it is attached to a thick layer of connective tissue, and that is your dermis. So this is a dry membrane. So here we have our cutaneous membranes. The mucous membranes are called mucosa. They are going to line body cavities that are open to the exterior. So things like your digestive tract, your respiratory tract, and your urogenital tracts. They are moist membranes, and they will be bathed by secretions or in the urogenital tract by urine. The epithelial sheet lies over a connective tissue layer called the lamina propria, and these may secrete mucus. And there it shows our mucous membranes. The serous membranes are called serosa. They are found within a closed ventral body cavity. We've talked about these whenever we talked about the pericardium before. And these you're going to have a simple squamous epithelium, so a single layer of cells. And it's called the mesothelium, and it'll rest on thin areolar connective tissue, which is a loose connective tissue. Is a loose. Try to write for y'all. And remember with serous membranes, they actually have two layers. You have the parietal layer, which is going to actually line the internal body cavity, and then you have the visceral layer that will actually touch the surface of the internal organs. And then in between those two layers, you will have serous fluid, which is going to allow things to kind of glide against each other and reduce friction. These are also moist, just like the mucous membranes. And with these, we have examples are the pleura, which surround your lungs, the pericardium, which surrounds your heart, and the peritoneum, which surrounds the organs in your abdominal cavity. So here we have our serous membranes. So as you can see, none of these membranes are actually open to the exterior. They're all enclosed. So think pericardium, the pleural cavity, and the peritoneum. All right, tissue repair. So how are tissues repaired when they're injured? So, tissue repair is necessary when you have any type of barriers penetrated. We also need tissue repair because cells must divide and migrate, and it occurs in two major ways: regeneration and fibrosis. I kind of mentioned regeneration in class. We talked about how regeneration is whenever you have damage to your tissue, it actually will replace that tissue with the same kind of tissue or the same kind of cells. So since it's the same kind of cells, that tissue will have the same function. In fibrosis, this is basically the formation of scar tissue. Scar tissue is a dense fibrous connective tissue that can actually be used to replace tissues as well. But with these, the original function is going to be lost because they don't undergo the same processes, and especially when you're talking about areas that need to be stretchy or elastic, it is definitely not going to be. If you've ever had knee surgery or surgery in an area where you have a joint, you know that you actually have to work out that joint and get that scar tissue to tear that's built up inside of there, or else you will not have movement within that joint. So 3 steps of tissue repair. The first step is inflammation. And what happens during the stage is your blood vessels will actually, and the tissue will actually release inflammatory chemicals. The blood vessels will dilate, so they'll open up and they will allow more blood to enter into that area. They also become very permeable, which means they're going to allow a lot of things to actually leave the blood vessels. And this is when we're also going to see clotting start to occur. So here's our picture of stage 1, or step 1, I suppose. So you've got severed blood vessels in this area. Here's your damage. So we see the blood clot forming in the wound. These are the chemicals that are released from the tissue that are going to allow and cause the blood vessels to actually dilate and to allow them to become more permeable. When they become permeable, it's going to allow things like white blood vessels to travel to that area. And then that's showing a vein over there. And here is your epidermis. Oh, formation of a scab is going to be occurring during this part as well. In step 2, it says organization restores blood supply. So biggest thing on this one is you're going to have formation of granulation tissue. If you have ever peeled off a scab and it was too early for it to come off and you notice that the tissue was very, very pink underneath, that is your granulation tissue. The epithelial layer will begin to regenerate. You'll also have fibroblasts producing collagen fibers to help bridge the gap. And those fibroblasts can actually be pretty much what can lead to formation of more scar tissue depending on the type of tissue you damaged. And then the debris in that area will be phagocytized by macrophages. So here we have, you'll notice the epithelium is starting to regenerate. This is going to be the granulation tissue forming. It is a very pinkish tissue. And here we have fibroblasts. Where did my, oh. Here we have fibroblasts that are going to be producing those fibers to help bridge this gap together. And then macrophages, which will be destroying any kind of debris or damaged cells in the area. In step 3, we have regeneration and fibrosis. So the scap is going to detach. You have fibrous tissue that's going to mature. So the epithelium thickens and begins to resemble the adjacent tissues and results in a fully regenerated epithelium with underlying scar tissue. And you can actually have more scar tissue depending on the extent of the damage. So this is showing stage 3. Here's our regenerated epithelium, and here is our fibrosed area or fibrosis or our scar tissue area. All right, so regenerative capacity in different tissues. So the tissues that regenerate extremely well are going to be epithelial tissues, bone, areolar connective tissue, dense irregular connective tissue, and blood-forming tissue. Smooth muscle and dense regular connective tissue have moderate regenerating capacity. And then things like your cardiac muscle and nervous tissue of the brain and spinal cord have pretty much no functional regenerative capacity at all. They are finding that some cells do show or undergo cell division, so they're trying to figure out ways to actually get them to regenerate better, so that way we can help improve people's, or improve regeneration of areas like cardiac muscle and nervous tissue. Whenever you think about it, those are probably the 2 most important areas of our body that we would want cell division to actually be able to occur. Developmental aspects of your tissues, you have what are called 3 primary germ layers in embryonic development, and these are going to form into the 4 primary tissues. So the primary germ layers are the ectoderm, the mesoderm, and the endoderm, and I'm going to go ahead and click to the picture so you can see it. So here we have a 16-day-old embryo, and you can see the 3 layers. Where are we at? 3 layers of tissue. So the blue area is going to be the ectoderm. Ecto is outside. And from the ectoderm, you'll form epithelium and nervous tissue. The mesoderm is the middle layer. And from this, you will form epithelium and muscle and connective tissues. And then the endoderm, this bottom layer, will form the inner lining of the digestive tract along with the epithelium. And then our last slide, aging tissues. So normally our tissues function well throughout youth and middle age as long as they have a good diet and you have circulation, good circulation to those areas. But as we get older, the epithelial tissues will thin with increasing age, and so they'll be more easily breached. Your tissue repair becomes less efficient. Your bone, muscle, and nervous tissues begin to atrophy, and then of course Increased DNA mutations are possible, and that increases your risk of cancer.